Okay, good morning, my dear students. Good morning to all of you. For today class, what I am planning to do, I will play the remaining part of the documentary which I played in the last class. I shown you a very good, beautiful documentary to you. I will play the remaining part. You watch.
Multi-story buildings are basically RCC structures, which should follow almost all precautions desirable for any RCC structure. However, there are some specific points which must be taken care of in the case of high-rise buildings. There should be enough strong columns to take the load of the building. These columns should be tied together so that the buildings will rock together as a whole and will not slide under the roof, which would be dangerous. Buildings with parking lots and such like on the ground floor are known as soft first-story buildings. Buildings with a soft first story should be avoided. Soft stories attract large earthquake forces and require very large ductility. To make the stiffness of the ground story comparable with that of the upper stories, large columns and beams and shear walls have to be used. The foundation plays a prominent role in the case of multi-storied buildings. Such buildings should preferably not be constructed on reclaimed land, such as filled-up marshy land or river plains. In sandy soil areas, the foundations have to go down deep in the form of raft or pile foundations. Let's understand this phenomenon through three models of houses, similar in construction, but with different types of foundations.
You have just seen the three buildings behave differently, having different foundation system, strip footing, and rough foundation, and with pile foundations. The building with the strip footing has sunk and tilted, and this has performed better. This whole thing is raft is closed. It did sink a little bit, but not much. Whereas this pile foundation has performed very well. It didn't allow it to sink or tilt. And this is the best foundation under such conditions.
Because such soils have a large water content, in the event of an earthquake, soil gets shaken up and densifies, causing the water to rise. This is known as liquefaction of soil. This causes buildings with weak foundations to either tilt or sink. Site selection. A geotechnical survey or soil exploration must be carried out to select the site so as to avoid places of very weak soil.
Talking of earthquakes reminds me of another incident. It was in the month of February last year. The Bhuj tragedy was fresh in our minds. One day, my Bengali neighbor, Mr. Dasgupta, came rushing to me and said, "Nasir bhai, Latur mein ho chuka, ab Bhuj mein bhi hua. Agar apne Mumbai mein hua, to अपन कहाँ जाएंगे? अपन को तो ये भी नहीं पता कि अपना बिल्डिंग earthquake का झटका ले पाएगा कि नहीं." First, I tried to laugh away his fear, but later I thought seriously and consulted a structural engineer who told us that the building is safe and can withstand the earthquake shocks. But that left me wondering once again, what if his answer had been no? I expressed my doubt to him, and he told me that there is nothing to fear even if your house is not properly earthquake resistant. You can still make it so by adopting simple, cost-effective and convenient techniques. So don't panic. Just take the right measures.
There are ways by which an existing house can be made earthquake resistant. Any qualified structural engineer can advise you on this. For masonry structures, retrofitting can be done in the following manner. Improve the strength of walls by cement or epoxy grouting. In the case of stone walls, stitch the walls with through stones or steel bars. Attach wire mesh to the face of the wall and cover with plaster. To understand this better, let's go to Radhanpur in Gujarat. Here, people from nearby villages and towns are gathered to see how stone or rubble masonry construction can be retrofitted.
लेकिन वो ये देखने जा रहा है कि this particular specimen here is as traditionally built. So the traditional masons and carpenters were employed to construct this. Exactly similar was constructed the other one. After doing the construction similar like this, that was retrofitted by applying certain elements. This is the condition. This particular specimen on the point of total collapse, whereas the strengthened one is still standing. This is a very interesting phenomenon that always happens in stone masonry, that there are two layers of stones, one inside, one outside. At the time of shaking, the two tend to separate out and one of the layers tend to fall out. Now this is the weakness that must be safeguarded against. What do we do that? As you see here, these header elements, they were incorporated after the model was constructed. How they were constructed? A hole was made through and a steel rod was placed inside and concreted. So this becomes an element which connects the outer layer of the stones and the inner layer of the stones. Now, in this case, that particular happening will not take place. Another element that was incorporated here is this, which we call seismic belt or Bhukampi Patti. Now, this is installed afterwards by using a weld mesh or iron jali, which is fixed to the wall by means of nails or other fixing elements. And then this mortar is applied. Mortar has to be strong, at least 1:3, cement and mortar. Once we do that, then all these walls are integrated. Now there is another element that we have provided in this house that is to be seen from inside, not from the outside. That is a vertical reinforcing bar which goes at the corner of the two walls like this, and it gets connected to the foundation, connected to the roof. Now there are 4 such bars, one at each corner. So now 4 vertical bars, this seismic belt, these header stones, now they make this house earthquake safe. In addition, where we have these triangular walls at the top, those also have to be enclosed in this same Bhukampi Patti system. So this triangular wall also does not fall out. Now, another detail that you see here is that when we do this, the wooden rafters are now held down to this Bhukampiya Patti. So even they cannot be displaced by the earthquake. Also during cyclone, this roof cannot fly off. So in one go, we have taken care of the cyclone safety as well as the earthquake safety.
For the retrofitting of RCC-type buildings, the following guidelines should be applied. Visual inspection by an expert to identify the visible weaknesses of the building and requirements of in-situ testing and detailed dynamic analysis. A detailed dynamic analysis based on the actual in-situ strength of concrete may be performed to locate weaker members. The weaker members may be strengthened as mentioned earlier. To increase the strength of beams and columns, extra steel should be placed and jacketed with extra concrete. Steel jackets may be provided to columns and beams to improve the ductility. In the case of buildings with stilts, increase the column and beam sizes to avoid a soft story effect. Some RCC walls may be added at the ground story in such a way that these do not hinder the usage as parking. Steel bracings between the columns will also be helpful.
So far, we've told you a little about earthquakes and how they happen, as well as the different measures for earthquake protection in building construction, location, and design. But earthquakes will still happen. So you also need to know a little more about the forces released by an earthquake, the way they affect buildings, settlements, and human beings, and to learn some survival skills. Two of the most dangerous forces released by an earthquake are ignorance and panic. Together, they probably injure and kill more people than the earthquake itself. In the event of an earthquake, here's what you should be doing. And remember, what you don't do can be as important as what you do.
When an earthquake occurs, one must do the following. Hide yourself under a bed or table. If this is not possible, stand in a corner or under the doorway. If you are in a single-story building, go out immediately into the open. But if the building is multi-storied, then don't rush to the staircase. Also, if caught outdoors, the rules to be followed are rush to an open space. Now, let's see what we should not do at the time of earthquake, or even after the shocks are over. Do not use matches, lighters, camp stoves, and electrical appliances, and avoid any gas leaks. Do not light your kitchen stove. Do not use your phone except for a medical or fire emergency. You could shut off power at the control box if there is any danger to house wiring. Do not eat or drink anything from open containers near shattered glass. Do not create panic by spreading false rumors. Do not ignore other people in distress if you are not hurt. Assemble outside after the earthquake ends and do a head count to check on the status of the neighborhood. There are ways by which one can prepare oneself for a calamity like an earthquake. A torch, a helmet or a sturdy hat, shoes, a battery-operated radio, fresh batteries, drinking water to last 3 days, and food to last 12 days. These are things that should always be present in a house for basic earthquake protection. It takes time for a region shaken by the sudden onslaught of nature to come back to normal. However, technology today has made rebuilding and rehabilitation easier and more effective. This school in the Kutch area has been reconstructed entirely with the help of low-cost advanced composite products like jute coir composite boards, and rice husk particle boards. It's an effort by the Advanced Composite Mission of TIFAC, the Technology Information Forecasting and Assessment Council. In collaboration with Mohana Orthotics and Prosthetics Center, Chennai, and with technical inputs from the Madras Institute of Technology and IIT Chennai, TIFAC's Advanced Composite Mission has also given a new lease on life to many of the people who lost their limbs in earthquake disaster. These below-knee endoskeleton limbs are adjustable, aligning themselves with the body's load-bearing structure as it shifts. They're functional rather than just cosmetic replacement for severed legs, allowing a near-normal gait for those who use them. The composite limbs are lightweight, better in control, and more natural in appearance.
Telecommunications are the first casualty in an earthquake-affected area. On such occasions when nothing works, particularly in remote areas, a small gadget has often come to the rescue. Known as ham radios, these devices have played a major role in the recent Gujarat earthquake by communicating important messages. A small gadget, but a major device, which can come in quite handy when disaster strikes.
So you're coming very nice, Karan, and 5 and 9 clear copy with your rubber ducky. So
Ham radio has had a very important role to play in natural disasters, like the floods in Orissa or during the recent Gujarat earthquake. Amateur radio operators are often called ham radio operators. Ham operators can fill the communication gap within the shortest possible time. These operators use high-frequency, long-distance radio sets, as well as very high-frequency, short-range radio sets to convey messages.
Well, I hope you benefited from this program on earthquake safety. You see, there is a lot of research going on in this field, and many wonderful life-saving devices are being designed to help you survive the sudden violence of our dynamic planet. But the most important instrument that can make the difference between life and death will always remain this little gadget that's fitted on your neck. It's called the brain. And all it needs to work is the right knowledge. Knowledge that can prevent you from quaking with fear. Knowledge that can help keep your feet firmly on the ground. Goodbye. Take care.
Okay, the documentary is over. It's a nice documentary. Hope you would have benefited from this documentary, right? I will record your name for my record, right? 100% attendance. All of you are attending. All 26 of you are attending class. Okay, so full attendance is there. Very good. With that, with this, I will stop. Okay, today class. First, I will stop recording. Right.